This is Module 10, the very beginning of it, and this is going to be Module 10, Lesson 1, Represent Equations in Tables and Graphs. We're going to take a look right up here at our vocabulary from this chapter, or from this lesson, I mean. Many real-world situations involve two variable quantities in which one quantity depends on the other. The quantity that depends on the other quantity is the dependent variable, and the quantity that it depends upon is the independent variable. In general, the dependent variable is typically recorded on the y-axis. And y-axis, that's like when we start talking about graphing and things like that. So let's take a look at this first one right here. The Jackson family is driving to visit family members who live out of state. They record the following information about their trip. So in 2 hours, they drive 130 miles. In 3 hours, they drive 195 miles. In 4 hours, 260 hours. And 5 hours, 325 hours. And we're going to take a look right up here at A. Which of the two quantities is the independent variable? The independent variable is the hours, because the dependent is the miles. Dependent depends on the independent. So the amount of miles you go depends on how many hours you drive. If you don't go any hours, you're at 0 hours, you go 0 miles. And I would like to tell you, the first column is always going to be your independent. Your second one is always going to be dependent. Let's look at B. How far does the car travel each hour? So to figure that out, right now we say 2 hours. So if I want to know for 1 hour, I would take 130, because that's the amount of miles you go in 2 hours. 130 divided by 2 is 65 miles. And how do you know? Because I did the work right there. So in 1 hour, we travel 65 miles. Suppose that D represents the distance traveled by the car in miles, and T represents the time in hours the car has been traveling. How can you model the relationship between the distance traveled in miles by the car and the time in hours using an equation? Use D for distance and T for time. So distance traveled, they said we're going to use D. And if you look here, that would be your miles is D. Your dependent variable always is by itself. Equals distance traveled per hour. We found that right there. That's 65. So D equals 65 times, times, and then we're going to do the time. They said to use the T. And the T would be our independent variable. So the hours is the T. The T, which is the independent variable, will always be next to your number. A student represented this relationship as 65T equals D. Is this correct? Yes, it's correct, because it's the same as this right here. It's just having the letter and number next to each other, and that means multiplication. Let's look down here. Let's get it all on the screen. Okay. When one variable depends on the second variable, the relationship between the variables can be represented in a table or by an equation. An equation can be used to express the dependent variable in terms of the independent variable. Pablo walks dogs after school. His earnings E in dollars are represented by this equation right here. So I have E equals 24H, where H is the number of hours he works. And here's our table. So this table is slightly different than the one that we had right up here. Instead of the columns going like this, we are going long ways. And again, on the top one will always be our independent variable. The bottom will always be our dependent variable. So in 1 hour, if I put that in our equation, I'm going to put that 1 in for H. So 24 times 1, that is 24. So I'm going to put 24 down. Next, we have a 2 on the top. So I'm going to put 2 in for h. And a letter and a number next to each other is multiplication, so we're going to multiply 24 times 2 and get 48. This next one's already done for us, so we're not going to do it. But then we're going to take this 4 and put it in for h. So 24 times 4, and that gives us 96. To determine values to the table, multiply each value of the independent variable, and our independent variable is h, by 24, because that's what it's telling us in the equation. We took 24 times h. To find each corresponding value of the dependent variable, which is e. Our dependent variable is e because that's the one that's on the bottom. The dependent variable depends on what the independent variable is doing. The dependent variable is always going to be the one by itself. The independent variable is going to be the one by the number. Each egg carton holds 1 dozen eggs. So here's our equation right here. We have n equals 12c. And that shows the number of eggs in one carton. So we're going to use this equation that I highlighted, and we're going to complete the table. The first one is done for us. I have 1 times 12 is 12. Now this other one, we have it down here on the bottom. So instead of multiplying by 12, we need to divide by 12. So 24 divided by 12 will get us 2. Next, we're going to put our 5 in for C. So I have 12 times 5, and that is 60. This one, I can choose to just divide by 12, or I'm going to, though, show you using our equations what we're going to do. So the bottom is in. We're going to put we're going to put 96 in for in. So we have 96 equals 12c. The opposite of multiplying by 12 is dividing 12. So I divide by 12 on each side. 96 divided by 12 is 8. So c equals 8. And I did it that way to show you the process of what you're actually doing. Most of you, with the one-step problem, you knew to divide by 12 off the bat. This is showing you the process behind that. B, to find the missing values in the table, sometimes I multiplied a value of the independent variable. And remember, independent variable is the one on top. So C by 12, because that's what the equation told us to do. A letter and a number next to each other is multiplication, so it's 12 times C. To get each corresponding value of the dependent variable, the dependent is in. Other times I divided a value of the dependent variable by 12. That is what I did here to get that. Okay, let's take a look at our next page. The distance in meters that Kesia hikes in X minutes is represented by the equation y equals 75x. So 75 meters per minute. We are going to use this equation to fill in the table. So a letter and a number next to each other means multiplication. So this is our independent variable. This is our dependent variable. I'm just going to take, since this is x right here, I'm going to take the 5 and I'm going to put it in for x. So 75, we're going to put the 5 in. So I have 75 times 5. That is 375. Next number I have is 15. So I'm going to take 75 times 15. And I get 1,125. Now, instead of multiplying, since I'm on the other side, I have to divide by 75. Because 75 is the number that we're using. So I have 1,500 or 1,500. And we're going to divide that by 75. When I do that, I get 20. Our next one, since it's over here, we're going to divide. So I have 2,250 divided by 75. And that gives us 30. How did you find the value of y when x was 5? So when x was 5, to get 375, I took 75 times 5. C, how did you find the value of x when y was 1,500? So when it was 1,500, to get 20, what we did is we divided. So we took 1,500 divided by 75. We're continuing the problem over here. We're making it a little longer than it was before. We're going to take this table and we're going to write them as ordered pairs. So to do that, we're going to look at the first line. We have 5 and 375. So I have a 5 and 375. The second line, I have 15 and 1,125. The third line, I have 20 and 1,500. And the fourth line, I have 30 and then 2,250. We are then going to take those ordered pairs and put them on the graph. I'm going to zoom in a little bit to get us down there so you can see it a little bit better. So when we put things on the graph, remember we're going to run and then we're going to jump. So I'm going to run to 5 and I'm going to jump to 375, which is about right there. Then I'm going to run to 15 and jump to 1,125. I am then going to run to 20 and jump to 1,500. Then my last one, I'm going to run to 30 and jump to 2,250, which is right there. Your point should follow a straight line pattern. Because Casey is hiking between the times represented by points, you can draw a line through the points. So if I draw my line, if you draw a little bit better than me, you can see it's in a straight line. It may be diagonal, but it is still a straight line. Okay, next we're going to check understanding. So make sure you're trying this first before you play this part of the video to see if you're understanding what's happening. So pause the video, see if you can do this, and then turn it back on to see how you did. Number 1, here's our equation. P equals 2/5 M relates the number of book pages P Alan reads in M minutes. What is the dependent variable? Remember, the dependent variable is the guy by itself. So this is our dependent. So I did that. Independent. This is our independent because it is by the number. And now we're going to complete the table. Remember, we're going to do, even though it's a fraction, we're going to do the same thing we did like with a whole number. So we're going to take this equation, which is 2/5 times M, because a letter and a number next to each other is multiplication. And we're going to take this stuff and plug it in. So our first one, M, is 10. So we're going to put 10 in for M. So I have 2/5 times 10, which is 4. Okay, our next one, we have P. We don't have M. So technically our 8 will go in for P. The opposite, though, is we're going to be dividing. So I'm going to take 8 divided by 2/5. If you want to know really what it's going to look like, though, I'll put my 8 in for my P. So that's 8 equals 2/5 M. And so to get to this point, we just divide by 2/5 and divide by 2/5. That's how we ended up with that right there. 8 divided by 2/5 is going to give us 20. So we're going to put a 20 in. Our next one is 12. And so we're going to take, instead of 8 divided by 2/5, we're going to take 12 divided by 2/5. And that gives us 30. Now we're getting back over here and we have an M on this side, so we get to put 60 in for M. So 2/5 times 60, and that gives us 24. Which leads us down to 2. A store sells a box of breakfast cereal for $3. So my money's $3. We're going to write an equation to relate the number of B boxes to the total sales. So we have to figure out if B is going to be the independent or dependent variable, and which one T is going to be. So do the boxes depend on the money, or the amount of money you get depend on the boxes you sell? And so I think it's that one. So the sales is dependent on how many boxes you have. So I have T equals, then I have each box I buy is worth $3. So we're going to be multiplying. So T equals 3B. And that is all you had to do on number 2. Okay, we're going to flip over to the next page. And this is a very long, what do you remember? Well, it's not too long. It just looks long. So bear with me here. The total cost C in dollars to dry clean a certain number of shirts, S, is given by this equation right here. What is the dependent variable? Your dependent variable is going to be C because it's by itself. The independent variable is S because it is multiplying by something. Now we're going to complete the table, and we're using this equation right here, and I'm going to put my work right here so I have some space. S is 3, so we're going to put 3 in for S. A letter and a number next to each other is multiplication. So I'm going to take 3.25 times 3, and that gives us 9.75. Put that down low enough so it looks like a decimal. On this one, instead of multiplying by 3, we're going to divide by 3. So we have 16.25 divide by 3, and that's going to be 5. Now, we divided on this one because instead of the number being on top, it was on the bottom. Same things with this one. We're going to take 3.25. I'm sorry, we're dividing by 3.25 because that's the number here. So on this one, we're going to take 26 and divide by 3.25. And we get 8. And then our number goes back up on top. So we're going to multiply again. 3.25 times 10 equals 3250. We're then going to take all that information and we're going to come down here and put on the number line. So we are going to run to 3 and then jump to 9.75. Now I know that these decimals are not on the number line, so just get as close as you can. So I'm going to run to 3 and jump to $9.75, which is right below 10. I'm going to check it off to make sure I knew that I do that. I'm going to run to 5, and I'm going to jump to $16.25, which is just a little bit above 15. I'm going to run to 8 and jump to 26, which is just a little bit above 25. And then I'm going to run to 10 and jump up to 3250, which is between 30 and 35. Now, should you draw a straight line through the points on the graph, or should you leave them as separate points? So we are talking about shirts in this equation, so we cannot have anything but a whole shirt, so we are not going to be drawing a line through it. And then our last one, it looks longer than it actually is. It's actually not too long. Dennis is floating down the river on a raft. The table shows the distance he travels over time. We're going to write an equation that represents the number of kilometers, K, he traveled in 8 hours. So first, let's determine the independent and dependent variable. Remember, the independent is always on top. The dependent is on bottom. Our letters are K and H. The dependent variable is going to be by itself, so I have K equals something, and then I'm going to have H. So to figure out what number is, we have to figure out how to get from the top to the bottom. So I'm going to do just with the whole numbers to make it just easier for me to type it into my calculator. So to get from 2 to 3, I'm actually going to take 3 divided by 2, and that's going to tell me how to get there. So if I take 2 times 1.5, I will get 3. And it's going to be the same thing all the way across. So if I try this one, if I do 3 times 1.5, I get 4.5. So that is what I'm multiplying by. So I'm going to put 1.5 right next to H because a letter and a number next to each other mean multiplication.